Good day, everyone. I'm Bianca, together with my groupmates Wax and Carla, and today we're going to talk about our Do Your Own Experiment project, which is entitled Catch the Red Light. This is what our group will discuss. We will be starting with the introduction of the project, followed by the Arduino IDE software. Lastly, we will discuss the hardware and the software of the project. Catch the Red Light is an Arduino based game which needs only one player. The task of the player is to press the push button when the red LED is lit up. Before all else, the serial monitor will read, "Welcome to Catch the Red Light. Your goal is to catch the red light." When the player presses the push button while the other colored LEDs are lit up, the serial monitor will read, "Sorry, you did not catch the red light. Try again," prompting the end of the game and signaling the start of a new round. When the player presses the push button while the red LED is lit up, the serial monitor will read, "Great, you caught the red light. Congratulations," signaling that the player wins and the game ends and a new round starts. This is how the program will run. To program this, we will be using the Arduino Integrated Development Environment or Arduino IDE software. The Arduino IDE software is used to write and upload programs to Arduino boards as well as other vendor development boards with the help of third-party softwares. It contains sketches, a text editor, a message area, and a toolbar. It connects to the Arduino board to upload programs and communicate with it. Sketches are what is known to be programs written using the Arduino IDE software. These sketches are written in the text editor. The message area gives feedback. Once the sketch is compiled and uploaded, may it be in the form of saving, exporting, or displaying errors. The toolbar buttons allow users to verify and upload programs, create, open, save sketches, and open the serial monitor.
So this is the code for the experiment catch the red light. So to start, let us define void setup. Void setup is the part of the code where you want to run once. Under this part, we have specified that pin 3 would be our input as defined by pin mode. So next is the for code, which is to specify that pins 9 to 13 will be used as our output. So the code serial.println is used to denote the statement that we want to present. In this case, those statements are welcome to catch the red light and your goal is to catch the red light. It is noticed that we use ln in this code, which states that the next line would be below the previous line. And otherwise, if we do not add this ln code, the statement would run indefinitely to the right. For void loop, this is the part of the code where you want to run unendingly, thus in a loop. In this part, we have specified the functions we want to see. Digital write is used to present the output. In this case, we have specified that the LEDs will present the output. High is used to denote the positive outcome. In this case of the LEDs, this means that they will light up. The if-else statements are used to factor in different occurrences to their corresponding output. the if statement, we have specified that pin 3 will be the input as denoted by digital read, which is basically reads the input. High is denoted that the button is pressed. The condition and, which is symbolized by two ampersands, means that both conditions are met to yield a positive result. In this case, button is pressed at the same time that LED, the red LED is lit, which is connected to pin 11. If both conditions are met, it will present a statement, great, you caught the red light, congratulations. While the else statement covers all the other possibilities and combinations that are not on the spectrum stated in the if statement. In this case, the else statement covers when the button is not pressed when the red LED is not lit, or when it is not pressed when the red LED is lit. Then the delay means what it says, which is the pause encoded in milliseconds. So in this case, 1000 is equivalent to 1 second. So if the stated conditions are met, like when the button is pressed when the red LED is not lit, or when it is not pressed when the red LED is lit, it will present a statement, sorry, you did not catch the red light, try again. Afterwards, this digital write will send the signal to all the LEDs to turn off. So that's it for the code for the digital interpretation of the catch the red light.
For the catch the red light experiment, this requires the following materials: the Arduino Uno board, USB cable, the breadboard, 5 LEDs, preferably of different colors with a red LED as constant, a button or switch, 12 jumper cables, 2 resistors, one 10,000 ohm resistor, and one 330 ohm resistor. For the setup, one jumper cable will be connected to the 5-volt pin and the other end to one of the ends of the button. The second jumper cable will be connected to pin number 2 and one to the end of the button. And then the 10,000 ohm resistor will be connected to the negative column and to the button. While 5 jumper cables will each be connected to a specific pin from pins 9 to 13, then connected to the negative end of the LED. While the positive end of the LEDs will be connected to the positive bank using 5 more jumper cables. Lastly, the 330 ohm resistor will be connected to the negative bank and the ground pin. So this is the top view of the setup, while this is the side view of the setup.